Ladies and gentlemen, it's time for our next video, and again, we're working with inverse trig functions. Okay, so to start, I want to review and just remember that when we're working with sine, when we're working with sine inverse, and actually I'm just going to go ahead, I'm going to draw all of my axes right now. Oh, good axes, Mr. R. Okay, so when we're talking about sine, here's 0. We want the easiest places that will give us both positive and negative values. Alright, positive and negative. And why do we need positive and negative? Well, because sometimes our ratios are negative. Alright, so we need to know, excuse me, from 0, where are the easiest places to go to kind of look at for a positive inverse sine and a negative inverse sine. And that means I need to either go up into quadrant 1 or down into quadrant, oh my gosh, 4. Yikes. Which means I do not use quadrants 2 or 3 when I'm talking sine. Now please remember, going up from 0 means I'm going to pi over 2. And going down from 0 actually means I'm going to negative pi over 2. Okay, so remember, when we're talking quadrant 4 here, we're not talking going all the way around from 3 pi over 2 to 2 pi. We're talking about going from 0 down to negative pi over 2. So that means that our answers should always be in that domain. Alright. Now for cosine, we think the same thing. Where are the easiest places for me to look, but I need to have a positive option and a negative option? And well, we definitely think positive going up. Why don't we go down? Well, because cosine is still positive in quadrant 4, right? Positive cosines are in quadrants 1 and 4. So that means to get to our negative spot, we need to continue going into quadrant 2. Alright, all the way over to pi, and that means we don't use 3 or 4. And of course then our domain is 0 to pi. And what's really nice is you can just remember tangent, it's the same thing as sine. We know that tangent is positive in quadrant 1, and it's negative in quadrant 4, so go up or down and get rid of 2 and 3. Okay, so once again, we have negative pi over 2 to pi over 2. Alright, so this video, what I'm going to end up doing, I think, up until about question 17, let me mark this for you guys, should be pretty much all review. So 1 through 16, what I'm going to do is I'm going to tell you right now, I'm going to do these problems for those people that may not have a great grasp on how to solve these yet, or evaluate them, I should say, excuse me. If you're feeling okay on these, or you want to test yourself, what I'll do is I'll put a timestamp in the comments or whatever, so you can skip, or I guess pause, I should say, and then I will tell you when I'm done with 16 at the timestamp, and you can kind of check through your work, and then you can pick up the video. Okay? Okay. So, if you are still with me, I am going to go through 1 through 16 now. I'm going to try to go a little quicker and just kind of talk through the way I'm doing these. Alright? So, inverse sine of negative root 3 over 2. Negative root 3 over 2, I know is going to be down in quadrant 4. And I know that sine goes with y values. So I know that I need my y value to be negative root 3 over 2, which will be very careful. Normally, we could say that that's 5 pi over 3. But you remember, 5 pi over 3 is not in the correct domain. So we need to actually go negative pi over 3. Alright, what would a sketch of that look like? Something like that. Alright? Now, inverse sine of 1. Sine of 1 is straight up. And I know that the angle that would get me there to a y value of 1 is pi over 2. Alright, I keep going. I know that my cosine has to be 0. Well, that only occurs, especially cosine, because I have to be in quadrants 1 or 2. That goes right up here. So again, I'm pi over 2. All right. I keep going. I see I have inverse cosine, which means I know I am in quadrants 1 or 2, and I see that I have a negative half, which means I have to be in quadrant 2, something like that. And the angle there, well, when my x's are 1/2, that means that I'm working with pi over 3's, but in quadrant 2, that means it's 2 pi over 3. All right. For sine, root 3 over 2, I'm positive, so that means I'm up here in quadrant 1. My y value is root 3 over 2 at pi over 3. I keep going. My inverse cosine of negative root 3 over 2. So again, negative cosine, I have to be in quadrant 2, and my x value is negative root 3 over 2, which means I'm closer to the x-axis, which means I'm at a pi over 6. But we know that pi over 6, that angle in quadrant 2, is 5 pi over 6. Okay? All right, tangents. These are the fun ones. Please remember, this negative root 3 over 3, this does not help us currently. This has been rationalized. We need to unrationalize it. So we need to remember that we're really looking at this, negative 1 over root 3. And what's really nice about this is now we can use that trick, like almost the opposite of what we used to do. When we had the points and I told you to cancel out the divided by 2's, well, now we're putting the divided by 2's back in. So really, I'm looking at, and again, because tan is y over x, I'm looking at, let's see here. I'm looking at root 3 over 2 comma negative 1/2 would be my point. Again, I took my x and y and I put them over 2. How did I know to put the negative on the 1/2? Well, I know that if tangent has to be in either quadrants 1 or 4, well, it's my y value that has to be negative, not my x, because a negative x value would put me over here in one of these two quadrants. Okay? So now I know where my point is. Now I should be able to get the angle. Let's see here. That looks like a pi over 6 angle. And because you're going down, it's negative pi over 6. Okay? Okay, this next one shouldn't be too bad. Tangent, when it's negative 1, we know what our angles are. We know that those are the pi over 4's. The only thing you need to think about is that because it's negative, you're down in quadrant 4, right? If I sketch this, I'd be down here. So that means I went negative pi over 4. If you said 7 pi over 4, remember, you're in the right spot, but 7 pi over 4 is not in the correct domain, okay? All right, if we keep going here, okay, inverse tan of root 3 over 1. So I put it over 1, and again, I do the same thing that I did before. I say, well, this is y, this is x, so I have 1/2 comma root 3 over 2, and I know that when my y value is root 3 over 2, I'm working with my pi over 3's. I'm in quadrant 1, of course, so it's positive pi over 3. All right, let's keep going. Oh, we're moving on to some doubles. Good. These are a little trickier, but not too bad. I take the tan of pi over 4. Okay, so this is forwards, right? This is what we've done before. I know that the tangent of pi over 4 is just 1. And now I need to take the inverse sine of 1. Well, where is my y value? 1. That is at pi over 2. And actually, I should write this here. My bad. Pi over 2. All right, so let's get in the habit of rewriting. So inverse cosine, and now we have to actually get the sine of 5 pi over 4. Well, if you need to draw a picture, you can. I'm thinking 5 pi over 4 is down in quadrant 3, and my 5 pi over 4 means that I would have a y value of negative root 2 over 2. Now when I take the inverse cosine of this angle, I know I have to be in quadrant 2 this time, right? cosine when it's negative, or inverse cosine, excuse me, when I'm taking that of a negative ratio, I have to be in quadrant 2, and I just need the angle that gives me an x value of negative root 2 over 2, which in this case should be, let's draw a quick little, I put that in a terrible spot, my bad guys. Let me put this over here. That would be over here, which is 3 pi over 4, okay? I am super sorry about the location of my first set of axes. Alright, let's keep going. Alright, inverse cosine of blank equals, alright, cosine of negative 2 pi over 3. Well, negative 2 pi over 3 should be where? Down in quadrant 3. Alright, down in quadrant 3. And I know that the cosine of that, or the x value, should be negative 1/2. Now, when I take the inverse cosine, or if I draw a little picture, again, inverse cosine means I need to be in quadrants 1 or 2. So because it's negative, I'm going to be right up here, and that looks like 2 pi over 3 is the angle, right? If my x value is negative 1/2, I'm here at an angle of 2 pi over 3. Alright, let's keep going. Alright, cosine of negative pi over 6. Alright, we're down in quadrant 4, and I want an x value. That should be, what are we thinking here, guys? That should be root 3 over 2. Root 3 over 2. Why? If I just go down a little bit, that means I went farther in the x direction, so that's my root 3 over 2. Now, it's telling me to take the inverse cosine of root 3 over 2. Well, the inverse cosine of a positive ratio must be in quadrant 1. So when I sketch it, I should be going up. So let's see here, right there, my angle would be a pi over 6. Alright, let's keep going, we're almost done. Sine 3 pi over 2. Oh, we know this. The sine of 3 pi over 2 is just, what's the y value at 3 pi over 2? Well, that's negative 1. And we also know that when we want the inverse tangent of a negative, we have to be in quadrant 4. And we actually already did this one up above. We know that we're down here. So we have to just remember that that angle that we're talking about is not 7 pi over 4, it's negative pi over 4. Alright, let's see here. Oh, last couple. The inverse cosine of pi. Okay, so I'm looking for where my x value is pi. Oh, pi's like 3.14. That's way bigger than the unit circle, okay? This is undefined, or no solution. Hopefully that makes sense, right? Like, we can't take the inverse cosine of pi, because again, pi, that's not really a ratio, that's more of an angle. And we can only take inverse cosines of ratios, or values. Alright? Wait, same thing on this one, right? We just talked about how you can't take the inverse cosine of something bigger than 1 or less than negative 1. Well, same thing here. Nowhere on my unit circle do I have a y value of 2. So this again is undefined. Alright, so hopefully those of you guys that just kind of tested yourself or quizzed yourself are coming back, and we're gonna work a little bit on number 17 now. And actually, my bad. Let me show you all of the answers for those of you guys that are just joining back. Okay. All right. So 17. We need to talk about this. We want to take the inverse cosecant of 2. So now this is interesting in that we know that cosecant and sine are inverses of each other. Or not inverses, excuse me, geesh. They're reciprocals of each other. what I need you to remember here is what's happening when we take the sine of an angle and the cosecant of an angle. It's the ratios that are flipped, correct? The angle doesn't flip. It's the ratio that's flipped. So what I need you to think about here, guys, if you see cosecant inverse of 2, you need to rewrite this as sine inverse of 1/2. And hopefully, again, that makes sense. We know that it's the ratio or the fraction that's flipped. So this should just be pi over 6. Because if we draw a little sketch, yep, 1/2, yeah, pi over 6. Okay? So I should have been boxing these all along. Sorry, guys. Okay. When we take a look at something like 18, well, we're going to take the cosecant of the inverse cosine of root 3 over 2. Okay, so let's see here. Root 3 over 2, x value, correct? X value is at pi over 6. Pi over 6. Now we need to take the cosecant of that. Well, what do we say here? Cosecant is really the reciprocal of sine. Okay, so we need to get sine and then flip it. Well, sine of pi over 6, our y value is 1/2, right? So when we take the reciprocal of that, we should just get 2. Let's move on. Inverse cotangent of root 3. In this situation, I know we just talked on 17 about flipping. You don't necessarily have to flip this one because we know cotangent is just x over y instead of y over x. So in this situation, I really just know that my point, instead of being 1/2 comma root 3 over 2, it's going to be root 3 over 2 comma 1/2. So now that this is the point I'm talking about, I need to get the angle that gets me here. Okay, and the angle that gets me there should be, once again, pi over 6. Alright. Secant. Secant we know goes with cosine. So inverse cosine, and then again we flip the ratio. Negative root 3 over 2. Well, an inverse cosine has to be in quadrant 2, and my x value needs to be the root 3 over 2, or negative root 3 over 2, excuse me. So this should be 2 pi over 3. No! I'm so sorry, guys, my bad. This should be 5 pi over 6. Alright, last one on this page. Inverse cosine of negative 1. Well, the inverse cosine of negative 1 means I'm straight out to the left. So cosecant straight to the left should be an angle of pi. And then when I want the cosecant of that, well, cosecant is the inverse of sine, right? So my sine, or y value, at an angle of pi is 0. And when I take the reciprocal of 0, I get our favorite, undefined, or no solution. Okay? Alright, so to finish up this video, we're going to do some solving. We will start up at the top here. I think we actually already did this problem yesterday, or something extremely similar, so this will be good to warm up with. We got to remember a couple things before we start. We have to remember that if I take the inverse trig operation, or trig function, I take it of a ratio, and I'm actually going to add in value, right? Because you can take the inverse sine of some value. Like if we just think it's the y coordinate, it's more of a value than a ratio. But we know that that will always get us the angle. But we need to remember that we can always rewrite this, right? This is going kind of backwards, right? We talk about inverse operations as going backwards. So we take the inverse operation of the ratio to kind of undo and get us back to the angle. Well, we can always go forwards too. We can just take the sine of the angle to get the ratio or value. All right, so this is big. These go hand in hand with each other. They work kind of simultaneously, or they work together. And what I mean by that is I want to get this inverse sine of x alone, first by dividing by 3, because now I have inverse sine of some value is equal to pi over 3. And what did we just say we could do? We can rewrite this. We can rewrite this as sine of the angle equals that value. So now when we look, pi over 3, I could draw a little sketch if we need it. Pi over 3 would be up here, and I want the sine. Okay, so x is equal to root 3 over 2. I wanted the y value, so root 3 over 2. All right, same thing on this next one. I'm going to divide by 4. So now I have that the inverse cosine of x is equal to pi over 4. And again, this is kind of backwards, so let's write it forwards. The cosine of pi over 4 equals x. Well, at pi over 4, we could draw a little sketch, or you guys can just use your memory or minds. Well, root 2 over 2, right? At pi over 4, both coordinates are root 2 over 2. So root 2 over 2. That's a positive root 2 over 2. Sorry if that looks like a negative. Okay. So 24 and 25, they look super crazy, but they're not that bad. Okay? They're really, really not that bad. I hope you notice that we have tan inverse 2x, tan inverse 2x. So you can almost treat this like as an entire variable or an unknown. If I have 5 of these and 4 over here, well, let's get them all on one side, just like a normal algebra problem. Let's subtract these over to the other side. Well, that means I now have 1 tan inverse of 2x. What else can I do here? What else can I do here? Just like a normal algebra problem. We want to get, if we're trying to solve for this x, we need to get everything else over to the other side, right? So I'm also going to subtract 8 pi over 4. Because now that means that I should have, well, 7 minus 8, okay, negative pi over 4. This is nice, guys. Now we can use our trick. We can say, well, I can rewrite a function, or an equation, excuse me, that was backwards, forwards. So I'm going to say that the tan of negative pi over 4 is equal to 2x. And if I'm talking tangent of negative pi over 4, hopefully we remember that should be nice and easy. That's just negative 1, right? That's a root 2 over 2 and a negative root 2 over 2, y over x. Yeah. Okay, so negative 1 equals 2x, or x equals negative half. And our last one, last problem for the day. Oh, very similar to the other one. I got to move these over, right? I want to collect them on one side. So I'm going to move these over, and I'm also at the same time going to move that negative 2 pi over to the other side. So I should have 2 cosine inverse, or inverse cosine, excuse me, x over 3, and that needs to equal 2 pi. So now when I divide by both sides by 2, I should get inverse cosine x over 3 equals pi, right? Divide by 2, just to show my work. And now I rewrite forwards. The cosine of pi must equal x over 3. Well, when my angle is pi, I'm straight to the left, which means my x value is negative 1. Negative 1 equals x over 3 times 3 times 3, and we know that x is equal to negative 3. All right, so at this point in time, we should be getting much better at finding values of inverse trig functions and understanding the domains. And now we should be able to solve trig inverse equations. All right? I hope this stuff is starting to make sense and you're kind of grasping it. I will see you next time.